So I wanted to start by looking at those three forms of linear functions really briefly. I'm going to go at a fairly quick pace here, so you're going to have to ask questions if I've gone too far for you, too quickly for you. So there's the gradient intercept form. You do need to know them by name because you might be told express this in gradient intercept form or express this in point intercept form. So you do need to know these names. This is from Wednesday's lesson, so there's nothing new here. So there's gradient intercept form, there's point intercept form, and there's general form. They're all just different forms. And there's also a fourth form. There's probably more than that, but there's a fourth form which I've got on the whiteboard here. Sorry for video watchers. And it's called intercept form. It's kind of neat. It's x over a plus y over b equals 1. And sort of like if you said, what would the x-intercept be? You'd say let y equal 0, right? So if I let y equal 0, that's gone. I'm putting my hand over the y over b. And so I've got x over a equals 1, and therefore x equals a, right? So the x-intercept is a comma 0. And if I was looking for the y-intercept, then I'd let x equal 0. So if I let x equal 0, the x over a would disappear, and I'd be left with y over b equals 1, multiply both sides by b, you get y equals b. So the y-intercept would be 0 comma b. So it's a really neat way of expressing it. It's not in the course, but an activity I've got for you to do in about 10 minutes time does have a couple of questions using this intercept form. So I wanted to make sure that you were aware of it at least. So you won't be tested on it, but you will come across it, I guess. Now, in terms of all of these four different forms that I've either talked about or shown you, the only one I actually particularly like is the gradient intercept. All of them have something to offer. All of them have something. All of them demonstrate a relationship between the different parts of an equation. So the gradient intercept form clearly shows the relationship of gradient, y-intercept, and the y values, I suppose. The point intercept form clearly shows the relationship between the gradient. Sorry, I'm just going to point to it on the screen. The gradient and a point on the line. So that's kind of handy as well. And this one, I don't know. I guess the benefit of this one really is that a lot of equations express as something is equal to 0. And it's a fairly easy thing in this equation to work out the x and y intercepts as well. So is that an excuse for it? No, not really. The reason why, well, does anyone know why I particularly like this one other than familiarity? Anyone take a guess? Okay, the reason why I like this one is because I think it's the only one that really expresses it as a function. All of these are relations. They show how x and y are related to each other, or how the equation works. But given that we talked about a function having a set of values called the domain, the inputs, the x values, and then there's a rule, and then the output is the range, the y values, then this is the only one that really explicitly says, here is my input, here is the rule, and here is my output. Values from the domain are input into the rule, and what is output is a value from the range. And this is the only one that does that. The other ones don't. That's why I prefer it. But you need to know that if you wrote in your exam or a test, if it said to you, find the function, you are allowed to write it in point intercept form. Okay, you are allowed to do that. Personally, I would get it integrated intercept form myself, even in a test, because it's just me. I'd waste the 30 seconds doing it. But if you're kind of counting those 30 seconds up, then if you put it in point intercept form, it is legit, just not preferred for me. Does that make sense to everybody? Yeah. Hello. Okay, so what have I got? 3 minutes to go through the rest. I'm not going to make it, but let's see how we go. I'm going to try and push as hard as I can. What we're going to focus on today is, we did all this yesterday. You did exercise 2B. I'm not checking that you've done your homework, but I did ask you to have it completed by today. Exercise 2B. Hopefully you did do that, and if you've got any questions, you can ask me when we get into the practice part of the lesson. If you haven't done it, sucks to be you. Today we're going to have a look at this really quickly, stuff that you've seen before, so I'm just going to rocket through it, and you just need to tell me to slow down if you're not understanding. So, as I said here, my preference is y equals mx. Just Siri. My preference is y equals mx plus c, but we're going to look at, well, what happens if you're given information and you need to find the equation? So I'll do it really quick. And here we go. Example 1, gradient. Oh, Siri, shush. In example 1, we've been given the gradient in this case, and we've been given the y-intercept. Dead easy. I'll do it in a different color so it stands out. You would go y is equal to, well, I've been given the gradient. That's what value? M or C? It's M, right? So you just go minus 6x plus 2, boom, done. Yeah? And then if it says something like find the value of y when x equals 7, it would just be a straight substitution. Okay, example 2, gradient equals minus 2. This time we're not given the y-intercept, we're just given another point, 1, 5. Here we go. Y equals minus 2x plus c. So I've substituted in the gradient that I was given. Passes through 1, 5. So I would then put 5 in for y. I would put 1 in for x. And then I would work out what c is, which would be 7. Is that okay? I've just multiplied negative 2 by 1, then added 2 to both sides. And so the equation is negative 2x plus 7. Okay, all good? All right, FYI, because you're not used to it, I'm just going to show you how easy it is in point gradient form. I could have gone, so this is not example 3 I'm doing it, this is still example 2. I could have gone y minus 5 equals negative 2 outside of x, what is it, 1, minus 1, and that would be an acceptable answer as well. Okay? So you don't have to work out C, because this equation also represents the line. And of course, if I expanded it and added 5 to both sides, I would get exactly the same equation. So you can still get it that way. So starting off from the point gradient form is actually kind of a handy thing to do. Okay. Example 3. Any questions? Okay, example 3, passing through 2 points. So again, you could use the gradient formula to work out, first of all, work out M, and then substitute it in, and then work out C from there. Here's an alternative way of doing it, because I know that you've probably done that before. Let me do it from the point gradient formula instead. So I just pick one of the points, doesn't matter which one. I'm going to pick minus 1, 4. So I'm going to go y minus 4, that's the y coordinate, equals m, which I don't know, outside of x minus 1. So that'll be x plus 1. Does that make sense? Taking away a negative. Okay, now I can basically substitute in the other point, and I would get 2, 3. So that would be 3 minus 4 equals m. Let me see now, 2 plus 1. So from here, I hope you can sort of see, this is basically x2 minus x1, and this is basically y2 minus y1. So it's actually the gradient formula, but I've just come at it from a different equation, that's all. So it's basically the same thing. So simplifying, negative 1 is equal to, get rid of that, 3m. So m is equal to negative 1/3. And so I can write, I'll just zoom up on this so you can see it. So I can write y minus 4 equals negative 1/3 x plus 1, and I'm done. I don't actually have to work out C. But if I wanted to, I could. I won't do it because it's all fractiony, so I won't bother. But if I wanted to, I could expand this side and collect and add 4 to both sides, and that would put it into y equals mx plus c format. But in terms of satisfying what's required as a bare minimum, leaving it at that is okay. Any questions before I move on? Sorry, this is very lectury, but I'm just trying to punch through it. Okay, moving on. Told you I was going to be fast. Example 4, what happens if I'm given the graph instead of actual information? Well, basically, you need to be able to read off 2 pieces of information from the graph, 2 points. Now, I've been a bit more convenient here and given the y-intercept already. And what you can do is you can either set up the equation by substituting points in, and that's how I'm going to do it. Or, if you're good, you can work out the y-intercept if you're given it And you can work out the gradient just by looking at it. So what's the gradient for this? Rise over run? Yeah, well, not for a -1 because I'm going forward a distance. So it's distance rather than coordinate. So I've gone forward 1, then up 4. Or if you like, up 4, then across 1. So it's 4 over 1, which is 4. And that kind of makes sense. If I had 4 over -1, it would be a negative gradient, right? We know negative gradients go that way. So it needs to be positive. So in order to get from this point to this point, I've gone up 4 units and across 1 unit. And so that's a gradient of 4. If you can see that, great. The more you can observe from a graph and just apply it, the faster it is for you. But let me do it a bit more of the an old school way. I'm going to go y equals, I don't know what m is, so mx, and I do know what the y-intercept is because I've been given it on the graph, plus 4. Okay, now I'm going to substitute the point in that the other point, which is -1, 0. So when y equals 0, we've got -1m plus 4. Therefore, negative m equals -4, because I subtracted 4 from both sides. And m equals 4. Therefore, y equals 4x plus 4. Done. You okay? Okay. Anyone else? Alrighty. So that's probably the most efficient way really is to just observe the graph and say, oh yeah, I can see the gradient is 4, and I can see that the y-intercept is 4, so therefore it's 4x plus 4. That's probably the most efficient way of doing it. The second most efficient way of doing it would be this way. If you're not given the x-intercept and the y-intercept, you would basically go it would basically be a simultaneous equation. I'll say it really briefly. You probably have problems to do like it later, so but I'm not going to go through it. So you would basically put in one of the points here, and you would get an equation with m and c in it, and you'd put in the other point that you're given, and you get another equation with m and c in it, and then you'd solve it simultaneously for m or c, and then work out the other value accordingly. That's about as tricky as it gets for that kind of thing. Okay, what else we got? So graph from equation. This is the pertinent bit, I suppose. In order to get a graph from the equation, you need 2 points. Y-intercept and x-intercept are usually good choices. So that's basically it. We are sketching graphs. 99% of the time in this course, we are graph sketches. Conscientious students will want to get graph paper out and start measuring. That's not conscientiousness, really. I'm sorry. It's just over attention to detail for no purpose. Sketching is designed to be proportionally accurate, with you putting in critical points. But other than that, it should be a relatively quick exercise. Yes, you should use your ruler. Yes, you should label your axes. No, you should not measure off points. You should just estimate to the best of your ability. So here we go. Example 9. I'll leave it all zoomed out. Example, y equals -2x plus 4. So in all cases, I think the easiest thing to do is substitute in x equals 0 for 1 point and substitute y equals 0 for another point. So I would get this. So y-intercept, let y equal 0. Therefore, y is equal to 4, because the 2x term will disappear. And then get into this habit, off to the side, write it as a coordinate instead of just leaving it as y equals 4. When we do quadratics and cubics, there's going to be more points that you have to calculate. So getting into the habit of collecting points rather than just sort of doing some working out, I think is a really useful skill. X-intercept, let y equal 0. So I go, I'll do this in 2 lines. 0 equals -2x plus 4. Might even use 3. Subtract 4 from both sides, and I get -4 is equal to -2x, and therefore x is equal to 2 by dividing both sides by -2. So that would be the point 2, 0. Is that okay? Okay, so in slide 20, I then graph that. So my 2 points are 0, 4. So again, it's all judging by eye. So I'm going to go up to here. I'm going to say, all right, that's about 4 there, let's call it. So 0, 2 would be about half the distance. So I'm sort of going down half, and then I'm creating a box. So it's about there. So then I'm going to put 2 in. Now, by the looks of it, I'm going to be going downways. Does that make sense in terms of the graph? Yeah, it's got a negative gradient. Hey, feel free to head out and have a chat. No? Okay. So it's always good to double check that what you're graphing makes sense in the context of the problem that you've done. So I'm going to use my line tool here, and almost invariably I miss the spots I'm aiming for, but at least it's a straight line. I'll do it in red so you can sort of see it. Yeah, imagine that went through those lines. And don't forget, personally, I prefer to put arrows at the end. There's no need to label the line unless you're drawing more than one line on the graph. So if you were drawing 2 or 3 lines, particularly for a point of intersection, label the graph with the actual equation itself. So y equals negative 2x plus 4. But if it's just the one line, you don't really need to. Okay, apart from me missing those points, any questions there? Okay, moving on. I know, I'm not moving on. That's basically all I want to show you. What we're going to do now, I'm just going to keep the video recording for a second and pause it. What we're going to do now is we're going to do a Desmos activity. So rather than doing textbook work for the next 15 minutes, you're not going to get through the whole Desmos activity, but you can complete it by Monday. For the next 15 minutes, you're going to do a Desmos activity. If you go to Google Classroom, there is a post that says match my line. Now, if I can just have your attention just for 1 minute, feel free to get yourself ready as you're going, but if you could just look at the board, if you can do 2 things at once. When you start the activity, it looks like this. I just want to explain how to use it. It's really quite cool, I reckon, anyway. So this says, for each match my line challenge, plot a line that passes through the given points. So you're given information or you're given a line and you have to work out the equation that works for it. So when you click on next, this is an example here. Adjust the equation so the line passes through the points. So you can see it's got this point here. It's going through the origin, hence there's no no y-intercept. And it needs to go through this point here, which is 1, 2, 3, 4 across and 2 up. So what would I have to change the value before x to make that line, to make it go through that point? 4 across, 2 up, so the gradient is? Yeah, it's a half. It's 2 over 4. It's a rise of 2 over a run of 4, so 2 over 4, which then goes to a half. Now, you can put in 0.5, and that will work nicely, but they're not always nice decimals. So I just wanted to show you that if I go 1, then hit the slash key on my keyboard, slash, it turns it into a fraction, 2. So 1 over 2x, and then you hit submit, and then you just move on to the next one, and so on. So that's basically what you need to do for this activity. What I can do, just so you can see what I can see, which one is it? Nope, it's this one. There you go. Emma's surged ahead, 100% in front of everybody else. So you basically, I get to see what you're doing as you go along. I can see that Reese and Huxley, they've just done it now. I can now see that Emma's on to the next one and so on. So I can track progress a little bit. And that's basically how it works. I can also anonymize if you want to make it challenging. And on your screen, you will see a famous mathematician. So you can see how you're tracking compared to the rest of the class. So I'm going to give you till 9:10 to work on that.